Hi sir, hi guys, this is my report in networking. IT 221 Introduction. I'm Macdenberg G. Gatbonton, BSIT2C BPO. First is data communication. It is the exchange of data between two devices via some form of transmission medium. Example is ATM, mobile phone, internet, remote control, etc. Next is 5 characteristics of effective communication. It uses the same transmission medium and language, direct and indirect communication, mutual understanding, continuous process, use of words as well as symbols. Effective communication, this is important when communicating seriously. Try to simplify your thoughts before communicating your message. You must analyze the intent of each and every message. Consider the overall physical setting whenever you communicate. You must discuss with others where appropriate in planning communication. Be careful while communicating of the overtone as well as basic content of message. Next is data. Data refers to information presented in whatever form is agreed upon by the parties creating and using the data. When we say data, it says here that data is defined as facts or figures or information that is stored in or used by a computer. Next is 3 fundamental characteristics of data communication. One is delivery. The system must deliver data to the correct destination. Accuracy. Number 2, the system must deliver the data accurately. 3. Timeliness. The system must deliver data in a timely manner. When we say delivery, data must be received by the intended device or user and only by that device or user. Accuracy. Data that have been altered in transmission and left uncorrected are unusable. Time. This kind of delivery is called real-time transmission. Next is components of data communication. Number 1, message. It is the information, data to be communicated. Sender. It is the device that sends the data message. Receiver. It is the device that receives the message. Medium. It is the physical path by which a message travels from sender or receiver. 5. Protocol. It is a set of rules governs data communications. When we say message, popular forms of information include text, numbers, pictures, audio, and video. Sender. It can be a computer, workstation, telephone handset, video camera, and so on. Receiver. It can be a computer, workstation, telephone handset, television, and so on. Medium. Some examples of medium include twisted pair wire, coaxial cable, fiber optic cable, and radio waves. Protocol. It represents an agreement between the communicating devices. Next is data representation. Text, ASCII acronym, acronym. The acronym of ASCII is ASCII or American Standard Code for Information Interchange. ASCII is a code for representing 128 English characters as numbers, which each letter assigned a number from 0 to 127. For example, the ASCII code for uppercase M is 77. Next is eASCII Unicode. The Unicode is an international encoding standard for use with different languages and scripts. ISO, numbers, images, audio, video. Data flows. Number 1, simplex. Communication is unidirectional. Second is half duplex. Each station can both transmit and receive, but not at the same time. 3. Full duplex. Both stations can transmit and receive simultaneously. The simplex is a communication channel that sends information in one direction only. The half duplex. Both parties can communicate with each other but not simultaneously. The full duplex is parties can communicate with each other simultaneously. Next is network criteria. Performance. It can be measured in many ways. Transmit time. It is the amount of time required for a message to travel from one device to another. Response time. It is the elapsed time between an inquiry and a response. The performance of the network depends on many factors such as numbers of users, type of transmission medium, capabilities of the hardware, and efficiency of the software. Reliability. It is measured by the frequency of the failure, time it takes a link to recover from failure, and network robustness in an catastrophe. Security. How to network protect data from unauthorized access. Next is categories of network. Network is categorized with the following factors. 1 is size, second is ownership, third is distance it covers, fourth is physical architecture. These are the three categories. Local area network or LAN. Second is metropolitan area network or MAN. Wide area network or WAN. The LAN is or the local area network LAN or LAN. We're confident that you've heard of these types of networks before. LANs are the most frequently discussed networks. One of the most common, one of the most original, and one of the simplest types of network. Second is Metropolitan Area Network or MAN. These types of networks are larger than LANs but smaller than WANs and incorporate elements from both types of networks. MANs can span an entire geographic area. And the last is Wide Area Network or WAN. It's slightly more complex than LAN. A WAN connects computers together across long physical distances. Next is network. Network is a group of connected communication devices such as computers and printers. The example of network is the internet, which connects millions of people all over the world. To the right is an example image of a home network with multiple computers and other network devices all connected. Mid-1960s stand-alone devices. ARPA, Advanced Research Projects Agency. The ARPA is underworld development for the precursor of the internet, known as ARPANET. DoD, Departments of Defense. It is an executive branch department of the federal government charged with coordinating and supervising all agencies and functions of the government directly related to national security and the United States Armed Forces. 1967. ACM or Association of Computing Machinery meeting. ARPA, ARPANET. IMP, Interfaces Message Processor. The ACM is a US-based international learned society for computing. The ARPA was the first wide area packet switching network with distributed control and one of the first networks to implement the TCP or IP protocol suite. And the IMP was the packet switching node used to interconnect participant networks to the ARPANET from the late 1960s to 1989. 1969. ARPANET reality. 4 nodes. University of California, Los Angeles, UCLA. University of California, Santa Barbara, UCSB. Stanford Research Institute, University of Utah, NCT Network Control Protocol. Next is 1972. Vint Cerf and Bob Kahn Interneting Project. Transmission Control Protocol, TCP. Number 1 is encapsulation, wrap, then unwrap. Number 2 is data graph, UDP. Prioritizes time over reliability. Number 3, functions of gate between two networks. Next is shortly thereafter, TCP higher level functions. TCP or Transmission Control Protocol is a communication standard that enables application programs and computing devices to exchange message over a network. 1 is segmentation, 2 is reassembly, 3 is error detection. IP handle datagram. TCP or IP, Internet Protocol Trace. The IP is the Internet Protocol is the method for sending data from one device to another across the Internet. Next is physical topology. It refers to the way in which a network is laid out physically. The physical topology, the method employed to connect the physical devices on the network with the cables and the type of cabling used, all constitute a physical topology. The categories: mesh. Communication is point-to-point. The mesh is a topology commonly used for wireless networks. Number 2 is bus. Signals are shared with the backbone cable. The bus, if the backbone is broken, the entire segment fails. The third is star. Signals are passing through the central device. The star is like a hub or a switch. Last is ring, number 4. Signals are circulates within the network. The ring is each network device is connected to two others like points on a circle. Thank you for watching, guys, and stay safe. God bless. Thank you, sir.